Well, now that we know that there are three basic types of fingerprints found at crime scenes, we need to talk about methods for searching for these fingerprints as we find them at the crime scene. And we're going to talk about two basic types of searching methods. The first one is by using lighting aids, and the second method is a large group of methods that we call enhancement or visualization methods. When we talk about lighting as a way of searching for fingerprints at crime scenes, the easiest way to do it is to simply use a flashlight. If we're searching a door to a store or a bank that's been robbed, what the common thing will be done is to hold a flashlight at a side view or obliquely illuminate the latent fingerprint that's on that surface. The oily residues or even the visible fingerprints that are found on that surface will become illuminated. Now, fortunately, there are some new technologies available using lasers or alternate light sources that are light sources that have a fixed wavelength that can be used to help illuminate the oily secretions that are placed on a surface. And these come in many forms. They can be as simple as a flashlight that has a special light in the end of it, and where you need to use special filtered goggles to protect your eyes, or it can be a very sophisticated laser system that will illuminate the oily residues. The second step in our visualization or enhancement of latent fingerprints at crime scenes, or any fingerprints at crime scenes, is to cause the oily fingerprint secretions to chemically react with a colorless chemical and produce a colored result. So what that means is if we have a latent fingerprint, an unseen fingerprint on any surface, all we have to do is spray that surface with a chemical and then watch for the chemical reaction to occur. For example, iodine. When iodine reacts with the starch that's in the oily residue of a fingerprint, it produces a brown color. That means if we have a latent fingerprint at a crime scene and we fume it with iodine, we will eventually see brown fingerprint ridge detail appear. Another example is a chemical called ninhydrin. Ninhydrin is a chemical that reacts with the amino acids that are in the fingerprint secretions. When ninhydrin sees these secretions, it turns from a colorless appearance and reacts to give a purple or a violet color. So that means that if we have a fingerprint on something like a piece of paper, all we would have to do is spray this piece of paper with ninhydrin, heat it up a little bit just to speed it up because chemical reactions like to go fast with heat. Then what we're going to see are a bunch of fingerprints that are purple or violet in color. Now these chemicals that produce these colored results, there are hundreds, literally thousands of them. They're being discovered every day. So any fingerprint residue that reacts with a colorless reagent to give a color can be used. This particular method of enhancement is one of those physical methods, and what I'm using is a magnet that's in this particular wand to lift up black powder that has metal fragments in it, and then just simply leave it over the surface to be processed and dust it back and forth so that you can now see how the latent fingerprints have become enhanced or visualized on the plastic bag. Once they've become visualized, get the last little bit of powder off here, then it's a matter of using the lifting tape to lift those latents off the bag and put them on a backing card. Now the latent has been lifted onto the tape and it can be placed on the white backing so that it is now preserved and can be used later for the comparison. Now, when we talk about the third method for visualization or enhancement of fingerprints, what we're talking about doing is causing a chemical reaction to occur and then using a physical method to develop or enhance that fingerprint. And the most commonly used combination technique is by the use of superglue or cyanoacrylate. And literally what is happening with this particular combination method is, if we have a fingerprint on a surface, we're going to expose that fingerprint on the surface to the fumes of the superglue. Cyanoacrylate, or superglue, when it hits the air, polymerizes. And when something polymerizes, what it does is it rapidly repeats basic units. It forms a plastic. So think about this. We have oily residue on a surface. We put superglue fumes over the top of it. And literally what happens is a plastic coating goes on top of that oily residue. So that now all you have to do is apply black powder to it, dust it, and you have the fingerprint visualized. The combination method for enhancing or visualizing latent fingerprints involves the use of superglue. What we're going to do is place a few drops of the superglue in this plastic lid. It's going to be placed in our tank, and then the object that's going to be processed that contains our fingerprints is this soda can. So we have to open the superglue. It's always good to do this with supervision, especially for younger forensic scientists, then again some older ones too. And put several drops of the superglue in the cap, carefully not sticking your fingers together. Placing this in the tank and then putting our object inside the tank as well. Then covering up the tank so that the superglue fumes will have a chance to react and coat the latent. It will be set aside for about 15 minutes. Okay, this superglue tank has had a chance to run for about 15 minutes. It's filled with superglue vapors. They've covered any latent fingerprints. So we'll take a look at what now has occurred inside here. And we can see that the can now has a fine coating of what looks like a white film on its surface. And what has happened is the latent fingerprints, the oily residue, has been covered with the white superglue fumes. And there appears to be a pretty good latent in this area. So remembering that this is a combination method, what we're going to do now is process it with the black powder. So I have this very finely divided black powder. It's almost like the same material that they make pencil leads out of. It's a graphite, but it's just been crushed into really, really small pieces. So if I sneeze, it's probably because it's gone up my nose. So I've dipped the brush in here and just tapped off any excess. And now you can use your own creativity, and you can use what I like to call the paintbrush method. Put it on like this, or there's always something called the twirling method where you take the brush and you spin it. So let's try the combination, twirling and brushing. Now I've got the powder on there. Let's see if we can get some of the excess knocked off of here. And now we've finished the visualization and enhancement, so we need to attempt to lift that particular latent using the same fingerprint lifting tape we've used before. And it's just a simple process, once again, of smoothing the tape over the dusted area and making sure that you get a nice contact here, and then just lift it up. And then this can would be processed over the entire surface later, but for now the lifted latent is then deposited on the card, and there's the outline of the latent fingerprint that was coated with the super glue on the can and then dusted with the powder. Now, because this is such a great technique, I can lift this many, many times if I wanted to. In other words, if this lift wasn't as pretty or as usable as it could be, I can always take a new piece of tape, put a little bit less powder, and try and lift it again. You could do this almost 20 times because, remember, that oily residue is now super glued to the surface. When we use chemical methods, the best technique for preserving these fingerprints, once they've been enhanced, is to simply photograph them. Now, it's up-close photography, and it's very microscopic in nature. But we can't take that chemical reaction off the surface. We just take a picture of it. Then the photograph is used for our subsequent test to try and identify whose fingerprint it belongs to.